day. Welcome to the first lesson of JSC Physical Science in a series of 2 lessons. The topic of this lesson is properties of water and the test for water. The objectives of this lesson are to understand the chemistry of water, understand the chemical and physical properties of water, test for the presence of water using anhydrous copper sulfate and anhydrous cobalt 2 chloride. Let's switch over to hear what Jason and Susie are doing.
The past month we have had heavy rain throughout Namibia. We're really lucky to have so much rain.
Yes, it's true, Susie. Water is important in our lives.
Water is very important for all forms of life. Without it, there will be no life on earth. Namibia is a dry country. Water at our disposal is mainly from underground sources. Some water comes from dams, some comes from wells and springs or streams. Cities and towns prepare water for drinking in many ways. Water obtained from a river or lake is often not safe for drinking. Such water, as you can imagine, often contains organisms that may cause diseases. Therefore, water is treated before it is used.
We have previously learned about elements and compounds. Ma'am, is water an element or a compound?
What do you think?
I think it's a compound because it is formed when hydrogen and oxygen combine in a chemical reaction.
So does that mean that water can be broken up into these 2 elements?
That's right. To help you understand this process, let's take a look at what's happening in a small droplet of water. We call this the microscopic view. In this picture, you can see that water is made up of tiny particles called molecules.
I can see that all the molecules are the same.
Yes, they are all made up of 3 smaller particles.
That's a good observation, Jason. In one molecule of water, there are 3 atoms, 2 hydrogen atoms and 1 oxygen atom. The hydrogen atoms are joined to the oxygen atom by a covalent bond.
I can see from this picture model that water must be a compound.
Yes, the microscopic view really does help us to see that compounds consist of molecules made up of different atoms, whereas elements are made up of one type of atom. What happens between the atoms and molecules in the microscopic world will give a substance its special properties. Water has many special properties, and that's why it's so important to us.
That makes sense, but what are the special properties of water?
Water has many unique physical and chemical properties. Anyone can test for them. We can start by testing the physical properties of water. The physical properties of pure water are: 1. Water is a colorless, odorless liquid. 2. Water boils at 100 degrees Celsius. 3. Water melts at 0 degrees Celsius. 4. The density of water is 1 gram per cubic centimeter. Melting and boiling points are affected by atmospheric pressure. The higher you go above sea level, the lower boiling point will be, so the readings might differ slightly depending at which sea level readings was taken. Windhoek is 1,700 meters above sea level.
What do we need to test for the physical properties of water?
Okay, we need 2 samples of liquids to do the test on, and after the results of the test, we can conclude which one is actually water.
Sounds exciting.
Here we have all the equipment necessary to do the test for the physical properties of water. Here we have 2 unknown liquids labeled A and B, 2 ice cubes of the 2 unknown liquids, 2 thermometers, 2 spirit burners, 2 measuring cylinders, an electronic scale, 4 glass beakers marked A and B, 2 tripod stands, and 2 pieces of gauze.
Do we need to take notes when we do the different tests? I have a notebook here. Come, Jason, you can help me with the writing of notes.
Of course, you have to write down what you observe and the conclusion at the end. You can start to write down the first test, which is for color and odor, next boiling point, then melting point, and last density. Now you draw 2 columns for the 2 liquids.
Yes, ma'am, we will do so.
Come on, Susie, you help me do the test while Jason writes down the results. What is the color of liquid A?
Liquid A is colorless.
Okay, and liquid B?
Liquid B is also colorless. Well, there's no conclusion so far. All of them are colorless, so let's do the odor test.
Let's start with liquid A. Let me open the bottle. Remember, when you do an odor test, you never smell a chemical directly. Some chemicals have a very sharp smell. You open the bottle and you wave with your hand and smell the aroma. Come on, Susie, you do the test.
A doesn't really have a smell. It is odorless.
Okay, let's do liquid B. What does it smell?
This one sure really does have a strong smell. Our conclusion can be that A is water because it is the only one that is odorless, but we do not have enough evidence that that is the case. We need to do more tests. What about boiling point?
Let's pour some of liquid A into the glass beaker marked A. Now we have to get the tripod stand and gauze as well as the spirit burner ready. Light the spirit burner and heat the liquid. Let's do the same with the other liquid.
The liquids are boiling. Don't we have to measure the temperature while they are boiling?
Yes, we have to insert the 2 thermometers into the 2 beakers. After a while, you can take the temperature readings as they are boiling.
A's boiling point is 97 degrees Celsius.
And the boiling point of B is 94 degrees Celsius.
Well, our evidence is growing a bit more that A is water. Let's do the next test, which is the melting point.
Now we will take the frozen ice cubes of A and B and put them into the correspondingly marked beakers. Then we insert the thermometers. So Susie, you can take their melting points once they have melted.
The melting point of A is 1 degree Celsius.
And the melting point for B is 6 Celsius.
Now it's getting interesting. Let's do the density test and see what is the outcome.
With the density, there are a few things we need to do before we have the final answer. First, we need to determine the mass of each of the 2 liquids. We can take 50 cubic centimeters as a volume for each liquid. Let's determine the mass of the empty measuring cylinder. Let me put this on the electronic scale. Come on, Susie, read the mass of it.
The mass of the empty measuring cylinder is 75.1 grams.
Now we will pour 50 cubic centimeters of liquid A into the measuring cylinder. Come on, Susie, read the mass.
The mass of liquid A plus the measuring cylinder is 125.4 grams.
Now we will pour 50 cubic centimeters of liquid B in another cylinder. Come on, Susie, read its mass.
The mass of liquid B and the measuring cylinder is 120 grams.
Jason and Susie, I want the 2 of you to calculate the masses of only the liquids and then calculate their densities. Remember, density is equal to mass divided by volume. Are you done, you two?
Yes, ma'am.
Well done. So can you conclude which liquid is water?
I think liquid A is water because it is colorless, odorless, has a boiling point of 97 degrees Celsius, melting point of 1 degree Celsius, and the density of 1 gram per cubic centimeter.
Yes, I agree with Susie.
You two are correct. Remember, we will still need to do the chemical test for water. If water drops are added to anhydrous copper sulfate, the copper sulfate will turn blue. If water drops are added to anhydrous cobalt-2 chloride paper, which is blue, the paper will turn pink. Jason, now you must draw new columns in your notebook for the chemical test of the 3 liquids with anhydrous copper sulfate and blue anhydrous cobalt-2 chloride paper. Here we have the following: 2 liquids A and B, white anhydrous copper sulfate, blue anhydrous cobalt-2 chloride paper, 2 medicine droppers, 2 small beakers marked A and B, and a spatula. We can start with our test. Let's start with the test with anhydrous copper sulfate. I will put a spatula of anhydrous copper sulfate into the 2 marked beakers. To each beaker, I will add a few drops of the corresponding liquids. Susie, you must watch the color changes so that you can report to Jason.
The anhydrous copper sulfate in liquid A turns blue and in the other greenish, which means that liquid A is water and the other not.
Now it is time for the blue anhydrous cobalt-2 chloride paper. Let me take 2 strips from the book. I will dip the paper separately into the 2 liquids.
The blue anhydrous cobalt-2 chloride paper turns pink in liquid A but remains blue in the other liquid. Again, it proves that liquid A is water and the other one not.
Well done, the 2 of you.
Let's now recap what we've learned today. 1 molecule of water have 3 atoms, namely 2 hydrogen atoms and 1 oxygen atom. A compound is the chemical combination of different elements to form molecules. An element is made up of 1 type of atom. The physical properties of water is: number 1, water is a colorless, odorless liquid. Number 2, water boils at 100 degrees Celsius. Number 3, water melts at 0 degrees Celsius. Number 4, the density of water is 1 gram per cubic centimeters. Melting and boiling points are affected by atmospheric pressure. Density is equal to mass divided by volume. Anhydrous copper sulfate turns blue in the presence of water. Anhydrous cobalt-2 chloride paper turns pink in the presence of water. This brings us to the end of today's lesson. The next lesson in our series on JSC Physical Science will deal with hard and soft water. Goodbye.